All right. Can you guys hear me okay? Check. Cool. Since Gary brought all of us here together, I thought it would be appropriate to begin with a pearl of wisdom from him. Programmers, good at building machines with 17 meta knobs that turn the 90 underlying knobs. Bad at asking, why are there so many knobs? My talk today is about knobs, and I'm going to talk about sort of two themes. One is, if you're making a machine, how do you choose the knobs on your machine? And then once you have those knobs, how do you communicate those knobs to the people using the machine that you're making? And we're going to look at this through two different case studies. The first case study will be about hardware, and the second one will be about software. Okay? Cool. All right, case study number one, hardware. I wanted to talk about probably one of the oldest pieces of hardware that humans have had, namely the saw. So the Egyptians had the saw in the 31st century BC, and the original model of the saw was very simple. There were very few knobs at all on the saw. And over time, people started getting ideas. They were like, okay, well, copper's nice, but eventually, we figured out how to use iron and make different materials and things like that. We started adding more features to the saw. So this is a woodcut from the 1800s, and this shows a two-man saw known colloquially as a misery whip. And you can see it's a little more advanced. There's a second handle for a second person to use, and it comes with this pit that you can stand in when you're ripping a huge tree. And this is well and good. There are probably a lot of the buildings in this area were made out of lumber from saws like this. And then in the 1900s, after the invention of the electric motor, someone had the very bright idea of attaching the saw blade to a motor and putting a handle on it. So this is the first skill saw. This was from 1924. And then you can see there's more stuff going on here, and that sort of leads us to where we are today. This is a saw that I happen to own. This is a magnesium sidewinder skill saw. And you can see there's a lot of knobs on here. So there's this blade, and we have a blade guard, and there's this trigger, and there's like some markings on the front, and yeah, you guys can see there's like a protractor on there and everything. So like there's a bunch of stuff on this. And the question that I have is this too many knobs, right? If you kind of think about all the things that a modern skill saw can do, you might wonder, like, okay, well, all these knobs, but can we do better? Can we remove some of these knobs, or can we accomplish the same kinds of things with fewer moving parts? And there's a lot of different ways that you could try and tackle this problem and sort of think about this as a design problem. And one approach that I really like comes from a paper by Daniel Jackson. It's called Towards a Theory of Conceptual Design for Software. And the very high-level idea in this paper is that what you should do, if you're making something, is you should sort of list out all of the knobs that you have, what he calls concepts, and try and match those concepts up with the purposes that those concepts are trying to address. So in the case of the skill saw, we can do this. We can start looking at all the pieces. We can say, well, there's a saw blade, and the purpose of that is to cut lumber. And there's a blade guard, and the purpose of that is to reduce the risk of you cutting yourself. And there's actually, on modern skill saws, there's a clutch. So where you mount the blade to the motor, there's actually a little clutch in there. So that when if you're sawing through some material and the blade hits like a knot in the wood, or if you turn it sideways or whatever, the blade binds for some reason, the clutch will release the blade from the motor, and that's to keep the saw itself from starting to spin and flying out of your hands. And there's a trigger, so you can turn it on and off. There's this groove, so you can follow a line. There's all these knobs, right? And what's interesting to me is that if you actually list out kind of the purposes for all of the knobs on this, there's really only one purpose that's the same purpose that you would buy a saw for, namely to cut lumber. Okay, you don't go out and buy a saw because you want a blade guard or a clutch. These are extra things, and it makes sense why they're there, but it's not why you bought the saw in the first place. And once you realize that, or once you list it out like this and start to think about it, again, it makes you wonder, well, less is more. Could we get rid of some of these things while still retaining the original purpose of this machine? And I want to kind of propose a hypothetical to you to kind of try and answer this question, how you could design maybe a better saw with fewer knobs. So imagine you had this awesome blue crystal, that's kind of pointy, and this pointy crystal has this amazing property where it interacts with lumber in such a way that if you touch the point to some lumber, it'll split that lumber in very neatly into two pieces. So that's our new material, and if we go through this exercise again, you can say, okay, well, we have this pointy crystal, it replaces the saw blade, and it cuts lumber. That's great. Now we don't really need the blade guard because it only has this property with lumber. I mean, as you can see, you can just hold this thing, so you're not going to cut yourself with it. You don't need the clutch because nothing is moving. You don't need the trigger because it doesn't turn on or off. I mean, it's just this awesome blue crystal. Like you don't need any of this stuff. You don't need the groove because you don't even need to mark your work anymore. Like you can take your straight edge, you can take your crystal like a pencil, right, and just and cut your stuff in half. So, to answer this question, can we do better? Like, yes, this crystal is way better because there are fewer knobs, and it lets you do all the things that you would do with a skill saw without having to learn about all this extra stuff. And you might say, well, like, okay, this is great, Kevin, but this is kind of just this dumb imaginary thing, right? There's no material that has this property. And you might be right. Okay, I'm not an expert on crystals and lumber, but it makes you wonder, right? Like, what if we could make this crystal? Like, what if we could work in some domain where we had sort of absolute control and we could specify in precise detail exactly how one thing would interact with another thing. And that brings me to my second case study, which is software. And the software that I want to talk about is a project that my business partner and I have been working on for a while. And so we used to do a lot of work on the web, and we made a lot of apps and designs and things like that. And we really wanted a graphic design tool that would allow us to kind of explore our designs in a responsive way. So instead of kind of using Photoshop to draw something, we wanted to have a tool where we could like visually draw stuff, but then we could also say like, how does this work on a small, like a watch, and how does this work on an iPhone, and how does this work on the iPhone big and tall, and like all this different stuff. So we spent about a year and a half making a prototype of this tool, and then we made one of those very earnest, looking into the camera videos, and put it on Kickstarter. And we got about 1,000 backers, which is really great. So we put all of them in this little forum. And so if you ever do a Kickstarter, I highly recommend that you put them all in this private forum, because then you can kind of hang out with everyone and work with them. And then all the randos are like still on Twitter, and you don't have to, they're over there, and you can hang out with your friends over here. And so we did this, and I remember, during this process, talking with everyone about this tool and seeing how they're using it and stuff. There was this one designer, and he kind of opened up this bug report. And he opened up this bug report about margins and padding, and he was basically saying, hey, these margins aren't working, I'm putting them in, and it's not doing what it should, and it's a bug report, so I like jump in, and I put on my developer hat, and I'm like, well, actually, the margins and the padding add up in this, so it's really correct, like what it's doing, And we go back and forth, and he's just like really confused, and I remember he says to me, he's like, hey, this is incredibly frustrating. I feel like I'm stupid because what I'm trying to explain is wasting your time because your tool works the way that you think it should. And this really stuck with me because this happened, and I sort of have two options here. Like one option is to say like, well, this is just like some ding-dong designer dude, and he can't wrap his head around margins and padding, and like that's just too bad. And to be clear, if you choose that option, it means you're an asshole. So my partner and I were like, okay, no, this is not good, right? And we realized, like we are making this thing, we are making this machine, and so it's like our responsibility to design and communicate the right conceptual model. Like we put these knobs in there, so that's on us, and we need to really step back and think about that. Are these the right knobs? Are we communicating them correctly? So on and so forth. And so it's interesting because when we started, we both had done all this work on the web, and we'd very much internalized these ideas of like margins and padding, which are kind of fundamental concepts in CSS. And it never occurred to us to sort of question them. We were just like, yeah, we want a layout engine, so like we're going to have margins. Cool. And then after this designer raised this bug report, it really got us thinking about like, well, like what are margins and padding? Like what are they really for? Like what's going on? So we went through this exercise, just like with the skill saw. We said, okay, well, we have these two concepts, margins and padding, but what are they actually for? And I try to answer this question the same way I answer any question about computers, which is to ask Google. And Google said, the CSS margin properties are used to generate space. And the CSS padding properties are used to generate space. And you're like, okay, cool. We got our two things. We're controlling space. We have these two knobs. They both I guess, control spacing. This is neat. And for those of you who are not familiar with CSS, let me just walk through a quick example so you know what I'm talking about. So say you have this giant orange box, and it's inside this parent container. And if you see this, you kind of wonder, like, well, what's happening? Like, why is the orange box where it is? And it could be two different things. It could be that this orange box has some margin, and that's what's positioning it where it is. Or it could be that the parent has padding, and that's why it is where it is. And you could actually be both. And so now you have these two invisible things that kind of add up to like position it where it is. And so it's, okay, I can see what now, like we've like stepped back, we're like, okay, this guy is reasonable, intelligent, this person who brought up this issue. Like it is kind of confusing that we have these two things. And I was thinking about it some more, and I've realized, of course, there's a whole other thing that controls space in CSS called positioning, or absolute positioning. So in that case, if you have this, it could be that there's no margins and no padding, but you're like, oh, I've just positioned this child absolutely to be 50 pixels from the left. And of course, because we got these three knobs, they all actually interact with each other. So it could be that you have a left and a margin, and you also have padding, but it doesn't take effect on absolute stuff because reasons. And so this is like, okay, yeah, this is confusing. And there, at least, you might step back and think, okay, well, there's these three things, and there's sort of historical reasons, but at least we have these three knobs, they all control space. At least we can do all the things that we want to do with these three knobs, right? My friend, have you ever tried to center something in CSS? This is a very hard problem. And you might say, well, if you know the size of the parent and you know the size of the child, you can kind of do the math yourself and say, oh, I'm just going to position it here. But then, of course, someone takes their phone and they flip it sideways, and now it's wider, and then your thing is not centered anymore. And from the standpoint of a lot of front-end developers and users of CSS, this is basically an open research question, which you can tell because I tried to look this up on Stack Overflow. So this is the question, how to horizontally center a div in another div. And you can see if you zoom in here, it was first asked 8.5 years ago. It's been viewed almost 3 million times, and the last answer was 10 days ago. So we're still working on this problem. But the powers that be, the browser vendors and the W3C and everyone, they realize, okay, this is a problem. People want to center their stuff. What are we going to do? They decided to add this other knob. It's called Flexbox, which is it's actually pretty good, but it's a whole new set of knobs where you can you add these properties to the parent, and now you can finally center your things. But now we have these 4 knobs that all do the same thing. And Flexbox is even worse, actually, because margins and padding and positioning, they use words like top and left, which makes sense to normal humans, but then Flexbox has all these other weird property names like align, self, and just, and it's like, what is going on here? We have too many knobs, right? We got to get rid of some of these knobs. This is what we've realized. This designer was right. This is really confusing. Can we do better? And we kind of sat back and thought about this, and we realized, at the end of the day, when you're thinking about spacing, you're always going to have the situation. You're going to have your thing. There's going to be some space before it and some space after it, and that's it. You can't get any. As far as I know, you cannot get any simpler than this. And so we were like, okay, let's get rid of margins and padding and positioning and all this stuff in our little design tool and just replace it with the concept of spacing. And then that's going to control spacing. And let's just see how far we can get with this. So we did that, but we still have this problem about centering. And we're like, well, how are we going to solve this? And we thought about it a lot. And we realized, when you want to center something, really what you're saying, you're trying to make this relationship. You're saying the space before the thing is equal to the space after the thing. You don't care if that's 17 pixels or 37 pixels or whatever. You just want them to be equal. Then when you start thinking about stuff in this relational way, there's a bunch of other designs that you might want to make as a graphic designer. You might want to say, I want twice as much space before as after. Or I might want to divide this thing in two and have the first half be white space and the second half be this child. So there are all these kind of relational things that you might want to express. And you might think, okay, well, cool, this is when we're going to add a linear constraint solver to our tool, because obviously you want to make these relations and everything. It's no, you don't want to do that, okay? Because people are coming from Photoshop, and if we're telling them that their matrix is not invertible because they have too many constraints, it's not going to be good. That's way too many knobs. So we're like, how can we solve this need within the existing concept that we have? we realized we could do that if we just tweaked it a little bit. So we decided to introduce this new unit called stretch. And the idea of that unit is like you can use it to just distribute any leftover space along a certain axis. So if you wanted to center something, you could say, I want one stretch before and one stretch after, and then the layout engine will be like, okay, well, here's the size of the child, and here's the size of the parent, and like here's this leftover space, and so I'll put equal amounts before and after, and like now your thing is centered. And you can sort of do all the things that I mentioned earlier. So you could say you have twice as much space before as after. And because it's just this unit, it sort of fits in with the existing stuff that you learned already. You can say, I want 20 pixels before, and then the rest of it, I want half of it to be my little child, and the second half to be white space. And we're pretty happy with this, and we realized, like, as we started playing with this idea, that like all of these knobs that CSS Flexbox sort of introduced, we could express using this idea of the spacing unit. So you can use it to control alignment and justification, and you can do sort of things that are actually still very hard to do with plain Flexbox, and it's sort of this general thing that addresses all of these problems. And so once we realized this, we were very happy with the situation. So to recap that was sort of how you choose knobs as a case study. And the first step, and this is really the most important step, is to just realize you have too many knobs. And we spent a year and a half like building this whole thing, and it never even occurred to us to question CSS. We're like, well, yeah, they have these knobs, and this is the thing. And what? But once this one designer was like, this is really confusing. Like, what's going on? We're like, oh, yeah, this is really confusing. Like, there's a lot here. And then once we did that, it kind of let us step back and think about it more, kind of go through this exercise of matching those knobs to what they're actually supposed to do, and then try and simplify that. So that's sort of the first theme that I wanted to talk to you about, which was how to choose your knobs on your machine. And the second one is how do you actually communicate those knobs to people? So if you're making some system, you step back, you think about it, you make these choices, and you make the right knobs, and you're happy with your knobs. But you still need to communicate it to the people using your machine. They need to internalize what those knobs are and what they do and how they can use them to accomplish whatever task they're trying to accomplish with your machine. And I want to talk about this with sort of three principles that you can kind of take and hopefully use in your own work. The first one is, this is actually a technical term called information at the point of need. So if you Google this term, you'll find lots of great examples and other things. But the big idea here is that, like, let's be real, people are not going to read your manual. They're not going to read it. So if they need to know something to use your tool, you need to show it to them right when they need to know it. And in our case, because we're making this like very visual sort of layout tool, most all of the knobs we can actually show them visually. So we spent a lot of time after we did this layout engine sort of making these heads-up displays. So it would just show you sort of the values of all the spacing and sizings, like right in context, when you're messing with your design. So it's not buried like inside your little property inspector or whatever. Just as soon as you start playing with stuff, it's going to be like, hey, here are all the knobs that are in play right now, and this is why your design looks the way it does. The next principle that we try to follow a lot is sort of preferring recognition over recall. And between my partner Ryan and I, we like to call this the Denny's menu principle. So I don't know how many of you have been to Denny's, but it's an American diner chain, and most of the locations are open 24 hours a day. And what's great about the menu at Denny's is that it is completely usable even if, for whatever reason, you are functionally illiterate. So this is a page from the Denny's menu, and you can see there's like a bunch of text. There's like 8 paragraphs of text in the middle, but that doesn't really matter because 2/3 of the page is like all 8 of these sizzling skillets. So like you don't have to do any reading. You just like look at the one that you want, and you can like point at it, and then like you can order it. Okay, like this is not a mistake. Like the people at Denny's know what they're doing. So we wanted to use that principle in our tool to sort of communicate all the semantics and the capabilities and sort of the knobs underneath there. So this is an example of the control panel on the side of how you kind of lay out things in the system. And what we did is you can see there's these 3 buttons beneath both the horizontal and the vertical. And the buttons are just these things that you can recognize that will do hopefully what you want them to do. So if you're like, I want to align my thing to the left, like you can just click on this button. Or if you want to center it, you just click on this other button. And these buttons, like they don't twiddle any kind of hidden state or set any properties. All they do is they put in the values in the inputs above. But if you haven't internalized like what this stretch unit is or how you're supposed to think about things or express stuff, you can just see these examples and you click on them and it does the thing that you want. And then hopefully, if you're paying attention, you're just like, oh, well, all it did was like set this number in here. Like, it kind of teaches you what's going on. And the final thing that we did to sort of communicate this model, might seem a little strange, but we actually spent a lot of time introducing errors into the system. And errors, like, I guess the best way to sort of motivate why errors are helpful is to imagine situations where you don't have errors, which brings me back to CSS. So in CSS, you can use positioning to say, like, I want this 20-pixel wide thing to be 10 pixels from the left. Or you can say, I want it to be 10 pixels from the right. And if you resize this thing, it's going to stay pinned 10 pixels there. And you can even say, I want it to be 10 pixels from the left and 10 pixels from the right. And if you resize it, it's going to adjust the width to match. So the question I have is, what happens when you specify all three? And if you like gambling, this is a great time to turn to your neighbor and ask what they think, and place a bet, what you think is going to happen when you specify all three of these things. Because to be clear, if this parent box is like 100 pixels wide, you're saying I want a 20-pixel thing to be 10 pixels from the left and 10 pixels from the right. Like, this is impossible. Like, mathematically, like, you cannot do this. But interestingly, CSS will not raise an error. It will do something. And in some ways it makes sense for CSS because browsers have to sort of parse all this garbage on the internet with like broken tags and like things that just aren't like impossible. Like, it still wants to draw something for you. But if you're trying to build something, if you're trying to internalize how this model works, not having errors is actually very harmful because you might think that this is a reasonable thing to ask, and you will get away with thinking that because it'll still draw you a box somewhere. And this is a homework exercise. I don't know what happens here. In our tool, we have the same problem. So you could specify pixels all along an axis and ask for something impossible. But instead of just doing something, and sort of dropping one of those implicitly, we decided we should just raise an error. So we actually turn whatever you're working on into this little red box with an exclamation point. And if you zoom in here, we give you the error right in the control, and it says, like, hey, like, something needs to be stretchy here because this is not going to work. And if that doesn't make sense to you still, you can click on it, and it sort of explains a little more what's going on. And you can say, like, look, like, you can make the top part stretchy or the bottom part, or like the height can be stretchy, but like something has to be stretchy here for this to work. And this, again, it really helps you if you're learning, you're coming into the system. It sort of is not this, like, there's a lot of error messages have such a bad rap because they're so unhelpful usually. It's like, something went wrong, you were wrong, and then you have one button that's like, okay. But they don't have to be that way, right? I wanted to give a shout out about Elm's errors, and I was going to talk about that, but I haven't already did all that. So, like, and it's awesome though because, like, this is not rocket science, like, to make errors like this. If you're making a compiler or some other tool, you just have to think about like how things might go wrong, and then spend a couple minutes being like an empathetic human being and like just saying, how can we help this person like use this thing better? Okay, so that's all I wanted to talk about, and I want to close and just kind of implore you that if you're building some sort of technology, like whatever that technology is, if that's software, if that's hardware, please think of the knobs, okay? like you have to sort of choose the right knobs, think about why they're there, what they're actually supposed to do, and then once you've done that, try and think about how you communicate that to the people using your tool, and that way, if they actually understand the capabilities of your tool, they understand what all the knobs do, they're really empowered and they can use it to go on and make great stuff. Thanks.